Hi there. In this video I'm going to attempt to modify this wall lamp, outdoor wall lamp, important, FY1766-1 cob LED light. Okay, I guess. So I have two of these working for about 2 years already. I'm not sure if it's exactly the same model, but the thing is exactly the same, so maybe same product from a different brand, or maybe it was just a different packaging, whatever, doesn't really matter. But I need to modify one to make it work from a power bank. This is mains rated, so as you can see, from 85 to 265 volts, it can take anything, but power bank, that might be an issue. So let's see what we find inside, because I literally don't remember what was inside of the other two. So let's quickly get inside of this box. Do we have some kind of just some info in Romanian? Let us see. So this thingy, it's a warm light, 5 watts, 450 lumens, and yeah, again, warm white, 3000 kelvins, and it's freaking nice. Again, I have two of these working really well. But from a power bank, I will also ooh, what the? They tightened these things so much, man, but I need to untighten them to put it on the wall first. Why did they tighten them so much from the start? Anyway, that's weird. No, this is not strong enough for that. Be back in a second. Let's see if this goes a bit easier. Yeah, much easier. So the way of tightening, as you can see, it has a slope in there, and when you tighten the screw, it just pulls on this, so it latches onto the wall. They are obviously built for outdoors, so you will see that I do remember. You will see some rubber grommets in there. Even here one from silicone, I think, that seals where you put in the cable, but then again you have a hole right here to let any water out in case it gets there, and another one there. And if I remember right, I think I actually did seal mine on the ones that are on the wall. Can't tell you for sure, but anyway, I can tell you for a fact that and kind of scratching this, no water got into them, so they did work properly. Okay, was this the same design? So what is this sealing onto? It's just glued in there. Are you freaking kidding me? So it has a tiny edge. No, this is so yeah, it's different from what I already installed. Luckily, for sure, this one will not get any sort of water onto it. So for any Chinese design, there's a cheaper Chinese knockoff. So yeah, this can take, as you can see here, from 65 to 265, and will output from 9 to 10 watts, but it will only give 300 milliamp hours. So for me, it's gonna be decently simple. What I need to do is remove this thingy, keep it for other LEDs, and basically substitute my own. Hopefully it will actually have enough room in here. I think it will, one way or another. Oh yeah, it will. Obviously I will make sure it doesn't short, but it does have enough room in there, which is perfect. This thing can take even 5 volts and can increase it to whatever we need, and also can limit the current, and we will limit it. So we are not giving this thing 5 watts. I want to give it about 1 watt and see if there's enough light with 1 watt. Hopefully it is. But yeah, kind of a bummer, sorry, that everything that you buy, if you try to buy it again in a few years, just by the way it looks, nope, not the same product anymore. So that really sucks. They literally glued this thing on. I think the other one had a completely different design, honestly. Yeah, for sure it didn't have this type of driver, although this one actually looks fairly nice, so not an issue with it. There's the chip right there, stuck on this, but how is it stuck? Is it glued? Yeah, it's glued in there. There's glue. Yikes, so I will need to cut the wires and make sure that they reach what I need and connect them to this thingy. Yeah, luckily we will be running low voltage in this thing, so I have two on the wall that are running perfectly with mains power, but this for me it will be just low voltage because I really wouldn't want to put mains into this. The way they went about this seal, just look at this. So doesn't make any sort of sense. Look at how is this pushing it. No, the other one was completely different. I hate this. China, stop faking your own cheap products. It's just dumb at this point, honestly. It's, yeah, anyway. So let me modify this thingy and see what we can do. I want to do a test and see how much light I can still obtain when I'm lowering the current. Because again, I want to run this at a lower wattage than it's running now. So with this is not a normal way you measure the light, but I will do this exactly the same when it's converted to being run on 5 volts from USB. So for me, for my test, I will still understand if I'm having half of the amount of light, a quarter or something like that. So this is at 15 centimeters from it, straight in the middle. It's perpendicular in all directions. This will give me a measurement. Where is that one? To zero it out? No. Anyway, we are starting from about 10 milliamp hour. We are not yet connected. I'm measuring what's the output of this, so not what we are drawing from 230 volts. And this thingy will be into the wall. I think this will actually directly power on. Yeah, most likely it will directly power on. And it did. So I want to see... Oh, not AC. I'm an idiot. I want to unplug this. Let me actually set this. I want to see watts. 5 watts. So yeah, bang on what they said. But I need to unplug it to make sure it shuts off, because we need to be in DC, because I'm dumb and I forgot that this is actually taking DC. I need to zero it out more or less. I think this is the zeroing out button, yep. And plug it back in. Again, should go to about 5 watts, exactly what they said. So about 250 milliamps. And let me shut off my light in here. Only, oh, so we are over 2000. I think we are that close that basically we are maxing this thing out. Let me select range 20,000. Let's see. What about now? Can we measure it now? So it's wait a second, about 4,400 lux, not lumens. We are in lux mode. 4,400 lux at 15 centimeter while running on 250 milliamps and basically using 5 watts from the wall. To the bulb probably only about 4 watts, considering that we are also losing something in conversion. Okay, makes sense. Now let's modify it and see what we get. What I decided to do first before playing with this LED driver, just run this from my PicTech power supply and limit the current, I don't know, instead of 300 that it was getting, 300 milliamp hours that it was getting before, to 100 milliamp hours, and see what kind of level of light we actually get, if we get anything usable out of it or not. Because I want to see the minimum where this thing is still usable. And yes, for that purpose I'm putting this over the alligator clips, because I need to measure in the exact same way I measured before, to make sure that my results are somewhat comparable to what I did before. So basically kind of like this. Actually, no, sorry, kind of like this. And this thingy needs to be here. If I could actually open it up, power it on, range 20,000 lux. Make sure it's spot on in the middle and that it stays like that. Yeah, be back in a second. Change the setup a little bit just so you can see the power supply, this and also this. So yeah, but I'm measuring everything again. I will also allow it to draw 300 milliamp hours, so we can see if we are close to the original measurement. We do have some residual light because it's day outside, but that's about 10 lux, so we want more than that for sure. Let's so 6 volts, 100 milliamp hours. Let's see what happens. Basically nothing. Okay, I think we need to go higher. Still nothing. Hopefully I didn't do anything wrong. What was the voltage on this thingy? 9 to 20 volts. So yeah, we might need to go higher than this. Nope. Okay, so at 13 volts we are showing a sign of light, but that's not much. 14 volts it's beginning to draw, but we are still not in constant current. So at 15 volts it's constant current and it's stabilizing at 14.42. so even if I give it 16, it will not draw it because it's in constant current mode. It wants to draw more than that. So at this point we have 2000 lux. Let's see if I allow it to draw 200 milliamp hours, 3600 lux, and what it was before. Let me allow it to draw a bit more voltage just to make sure we don't run into voltage, but it's at 15 volts. We are still not at the limit. So this is what it was drawing before. 4,007, almost 4,650 lux, to be more precise, at 300 milliamps. Okay, and 15 volts. So this thing kind of wants about 15 volts. So let me see, we can get about half the light. Let me press on this. If we give it 120, I think we are even above, so maybe at 115 milliamp hours we are at about half the lux that it is at maximum. Heating up? No, has almost no idea it's running. Okay, I can work with this, I think. Let me do some math and see. So actually no need for that. Let's say we are at 15 volts, although we are not. But if I put 15 volts, I can take into consideration 0.1 amps. So that means at this moment it's using about 1.5 watts. Much less than 5 watts, isn't it? Okay, cool. So what I would say at this point, and this timed out, but anyway, you know the value. This thing is basically, let me try and power it on without having anything fall from here. Hopefully I can do. Nah, I couldn't do it. Oh damn it, and I am out of range. Stay there please. Anyway, something like that, more or less. We have half the light with, so 50% of the light with only 30% of the power usage. So we are running more efficiently at this point. Let me see what happens if I go even lower than this. Yeah, so we are dropping quite a lot. There's almost no light at this point. So yeah, I kind of need to run it at 1.5 watts to still have enough light for what I want. Okay, good test. This gives me all the info that I need. Damn it, this is only a step down, so this will not work from my 5 volts. This is step down, step up, but this does not have current limiting. This would also have current limiting, but damn it, so I need to do my own current limiting and use this module instead. You know what, I'm going to use one of these XY016. They are step up converters, really small, really simple, up to 2 amps. We are nowhere near that. This is up to 5 amps if I remember correctly, but this is a more expensive step up, step down converter. So why would use this when I can use this tiny thingy for what we need? Powerful enough, 15 volts, and it makes it from 5 volts. So that's perfect, but we still need to do the current limiting. Okay, so I've calculated. This is what our LED is using, 14.5 volts at 115 milliamp hours, and I was aiming for about 10 ohm resistor to drop the current, then to limit it at 115, and that means that we need to give 15.7 volts from that little module that can do constant voltage. So at that point our LED will be running at 1.66 watts, which in my opinion is good. And let me show you. At that point we are dropping 1.2 volts on the resistor, which is about 10 ohm, and it's 1.15 watts of heat it's dissipating. So yeah, I think that's quite decent. It will not overheat, it will not burn out. Let's test this. Okay, connected everything. Please ignore all of this, not in use. let's power on the multimeter, the current clamp in milliamps, allow it to stabilize, and then we'll do a zeroing out, more or less now. Wait a second. 0.1 milliamp hour. Never mind, we are quite close. Ah, come on, I want a 0. Let me try again. Really? You don't want to give it to me? Okay, we have a 0. Even moving it just a tiny bit shows us 1 milliamp. Anyway, this is set to 0.09 amps, so 90 milliamps, 15.7 volts, and I think at this point, let me turn on the light on this, maybe you can see it better then. Yeah, you can see it much better. Let's turn this thing on. You can see we have light, and we are using the whole power that this is giving, more or less. There are some small losses maybe in the wires, but it's almost nothing. So now let me start increasing. We are not at 15.7, so we are in constant current because we are using all of this power. Our resistor is not yet limiting the current reaching the LED. Start to increase it. You can see it also increasing in here, but why did this time out? Yeah. Again, increasing it. You can also see the voltage. Still increasing power also here. We are still not limiting with the resistor. Still increasing. Now we are in constant voltage. So now the resistor is limiting the current going to the LED, and we are at about 115. Exactly what the calculator on the website was showing us. 15, 16, it's, yeah. And I could go even further at this point. We are in constant voltage. Anything that I give above this will not be used because the resistor is doing what it needs to be doing and limiting at 115, 16, something like that. So it's, and you can see we are not drawing more, although we are allowing this to draw more. Even if we go to crazy numbers over 1 amp, you will see that it will not draw more than this. So that is where our resistor is limiting the current. So it's perfect and not heating up at all. So it's cold to the touch. Yeah, this thing will not care. It will run like this indefinitely. So now what we need to do is set this thingy to 15.7. Input will be 5 volt and resistor will limit the current, and we are done. Cool. Testing with the power bank that will actually power this through USB, because this has a nice USB. It will not be used like that, but for the moment it's good enough. It's a direct contact to the pads on the side. So this has about, let me try and show you. Yikes, be back in a second, or could I somehow? No, I cannot. So this has about 5.1 volts. Most USBs, power banks are between 4.9 and 5.1, around there. So at 5.1, 15.66. I think we are close enough to 15.7. If it would drop to 5 volts, this would drop to 15.56 or something like that. So that's good enough at this point in time. Let's power this and see how it likes it. Obviously through the resistor. Let's see. Will it go boom or not? Oh, you cannot see the boom in case it happens. Nope, it did not go boom. But I will check. for overheating, also in here. And I will also check the current to make sure it's okay, the voltage. So be back in a second. Current 110 more or less, so just a smidget lower. Probably the voltage is also just a little bit lower. Let me try to check it while still maintaining contact in here, because I'm just touching with wires. So 15.61, just a tiny bit lower. I can deal with this. I prefer on the lower side than to burn out that LED or the resistor. So yeah, really happy with the situation. Awesome. And we are still outputting a decent amount of light. Okay, just realized one thing. For my use case, it's actually better to have this in the control box further away from this and only have direct wires connected to this thingy, because a higher voltage will actually fare better on a longer wire. It's better than trying to get 5 volts at 10 meters in length. It's better to have a higher voltage at that wire length. And also I will be able to more easily change this in case I want more power or less power out of this, depending on how much our batteries accumulators manage to last. So yeah, basically this at the end of the day will be just a closed little boxy with a wire coming out of it and going to this at a bigger distance, when I actually have access much easier to it. And in the end, if I don't have enough juice in this, I can actually power it with its initial power supply, just connect it in that box to 20 volts and its voltage will come up to here. Even better than having 220 come up to here in its little thingy. So yeah, okay, that's about it for me. Trial done, learned what I needed, and now I can actually mount it on the wall. So hope this video gives you a bit of info on how these things work and how you can hack them a little bit to make them do what you want. In case it does, give this video a like and see you in the next one.